Well, this is the amplifier that I've been playing with, and yesterday I just intended to use the new dummy load that I'd built and just do a quick frequency response test. And to be quite honest, I had nothing but trouble. I don't think I actually had a real problem with it. I think probably what the problem was is I was just actually effectively overdriving the output. But one of the YouTube comments from Simon's was, "Have you checked the bias?" And of course I very flippantly just replied to that and I said, yes, of course I've checked it. But that was really a bit of a fib. I mean, basically what I'd meant by I'd check the bias, I'd put my hand on the heatsink and I'd look to see if it'd get warm. And I thought it was running pretty cool and I hadn't bothered to investigate it any further. Well, today I thought we'd have a look at that. One of the other suggestions for the overheating, I think, was perhaps I was upsetting the amplifier by the way I was connecting the output to the scope, or a signal generator, in that perhaps I was shorting out the output. So just for kind of information's sake, I just thought that I'll make a few measurements and then perhaps people that are helping me and making comments will be able to have a little bit more information and be able to provide a little bit more advice about what I'm doing or what I'm doing wrong. It's fair to say that I really don't know very much about audio amplifiers. In fact, analog electronics in general isn't particularly my bag, although I do it when I have to. So what I was saying is I didn't really believe I was shorting the outputs out, because everything on this amplifier, in terms of inputs and outputs, it's all referenced to the chassis. So if I just check my continuous in my meter, yeah, I got a bleep there. So this is the negative of the speaker output. That is at ground, that's just a bad connection. And that's the other speaker output, the right speaker output. So that's reference to ground, as are all the line-in connections and auxiliary connectors, whatever you want to call them. So I'll just go to the shell of the, do you call it an RCA jack? Perhaps you do, not sure. So everything is grounded. So I don't really see any way that connecting a test equipment with a grounded BMC is going to cause me a problem, because the outputs are already at ground. So connecting them to ground again shouldn't really cause any damage. Now I understand I could be causing a ground loop that could induce noise, but I don't think noise was the problem that I was seeing, and things appeared to be overheating. The other comment I had about this amplifier before is that it has a 2-core mains lead on it. Sorry, I don't know if you can see that, a 2-core mains connector, which I thought was a little bit strange. I don't know, is that a French plug? I'm not sure. Is it American? Well, the amplifier is definitely all set up for 230 volts, but yeah, I'm guessing that's a Continental plug. Maybe that was, I don't know if that's common or not, but it looks more like a shaver connector to me. But I'm rambling on, aren't I? The point I'm trying to make is this connector isn't earthed. But the amplifier itself does provide the facilities to earth it, in that there is an earth stud here, and the earth stud is connected to the chassis. So clearly this amplifier is designed, or is at least capable of being grounded. It does make me think that the electrical safety of something like this is a little bit dubious, in that it's a metal case with a metal transformer on it. It's not double insulated, in fact it's just the opposite. Everything is actually referenced to ground on the chassis. So it kind of makes me think, under a fault condition, if maybe this connector, for example, here is an auxiliary output to feed, I guess, other equipment. Well, that's at 230 volts, and I guess if, you know, and this fuse is also at 230 volts. So, you know, if any piece of, I don't know, metal work, or I drop a tool in there, or I guess whatever, a fault occurs, the transformer, the primary winding goes short circuit as can do. The whole body of this is going to become live, especially if there's no ground connected here. So yeah, I've got to admit, I'm a little bit surprised and confused by all that. I'm not used to working on metal equipment that isn't fitted with a ground. So if anybody has got any comments on that, yeah, I'd like to hear it. Maybe the first thing that you should do is you should take your two-core, you should plug your two-core power lead in, but you should actually use a separate ground connection. But I can't say that that was particularly safe. I'm pretty sure the intention of this ground connection isn't as a safety ground. It's probably like you would on what I would use on an old valve receiver, where you don't particularly want to use the house ground because you import a lot of noise into your radio and stuff. So what people used to do is, with radio equipment, in fact amateur radio engineers still do, they tend to employ their own earth grounding stake, which they know is going to be clean. So I suspect the purpose of this ground connection, it's nothing to do with electrical safety. It's all about just providing a clean ground source. So yeah, I'm just a bit surprised about the fact that this amplifier came with a two-core cable, and although it has provision for earthing, you know, there's nothing really to force you to do it. So again, if anybody's got any comments about that, I'd be interested in hearing it. What I think I will do is, because although I do work with high voltage things, no, that's not quite true anymore. What I actually do these days is just shuffle bits of pointless paper around. I used to work with high voltages and power supplies, you know, laser power supplies and big three-phase power supplies. I used to work on that stuff every day, but I'm just a paper shuffler now. And what I think I will do is, because all these connections are live here, this fuse here is okay. That's just a low voltage fuse supplying the dial lamps. But this fuse here, I believe, is the one that's feeding this auxiliary output connector, and it'd be very easy for me to put my hand on that. All this tag strip here is also live at 230 volts. So I think, just to give me a little bit more comfort while I'm poking around inside it, I think I might just put a couple of shrouds over everything. And yeah, might stop me doing something stupid, but I doubt it. We've got our thermocouple probes here, and we've got them stuck on the heatsink, and these are the output transistors glued down here, if you can see them. So what we're going to do is, I'm going to do nothing very much more exciting than, I'm going to plug it in, I'm going to switch the power on, and I'm going to leave it for half an hour. Let's just take a temperature reading. Top display is transformer, bottom display is the output. Top, TX, bottom, amp, and we've got 19, just calling me a liar, 19 degrees on the top and 19.6 on the bottom. I'm surprised they're not the same, because it's been left off all night, that. I guess one little check we could do while everything's just warming up, and maybe it'd be useful just to take a measurement when everything's cool. It's just to have a look at the output offset voltage, if we've got anything from the amplifier. So let's just have a look at that. So the left channel has got an offset voltage of, if I can get on there, let's call it 29 millivolts. And I'll write that down because I've got a memory like a sieve. 29 millivolts left, and the right channel just check, yeah, that was a minus offset as well, minus with reference to ground. Let's have a look at the right channel now. Where's the connector? There it is. Oh, 40 millivolts. Well, things have been warming up now for just about 10 minutes, and the power transformer is at 22 degrees, and the output the output transistor heatsink is at 28.5 degrees, and it's still climbing, but very slowly. It certainly doesn't feel hot. Well, I've been doing a little bit more digging around, and I've managed to come across a better circuit diagram that I found online. The original one that I had was totally unreadable. You could kind of see that there was resistors and capacitors, but you know, you couldn't read any of the markings or values on anything. And the other thing that I found is this general, I think it's kind of a general adjustment guide by Kenwood, and you know, it tells you how to adjust the DC offset voltage, which I think they're calling the center voltage here, and also the bias adjustment. Now, looking at this amplifier, it's not actually possible to do a center adjustment, or maybe that's not quite true, but the way you achieve it is actually by physically changing some resistors, or actually just replacing some of the transistors in the driver stage of the amplifier. But I had a look at the values, and what did we do? We made a note of them. Minus 29 millivolts on one and plus 40 millivolts on the other. Now, based on the little bit of reading that I've been doing, that is in the acceptable range. So I'm not gonna touch that. We'll leave them as they are. However, if you think it's wrong and it needs further investigation, tell me. But looking on a few forums, it appears that you know, anything up to about 50 millivolts is probably normal for kind of what is, I guess, a budget and amplifier. Okay, one of the other things that I said we was going to have a look at, though, or a few people have suggested I actually have a look at, is the biasing, which is the you know, the DC operating condition of these transistors. And what I've found is, and again, the information that this gives you, it's a little bit contradictory. I found a few different data sheets that list the KR-2600, and it would appear that there is early and late models, and again, I'm not sure which biasing arrangement applies to which model, because I've just found a few different values. But this data sheet that I've actually managed to find here, it lists a range of Kenwood receivers here, and it says that I've lost it, the KR-2600 should have a bias current of 25 milliamps. So what we'll actually do is, I think we'll just measure the voltage across the emitter resistors, and from that we can just calculate what the bias is at the moment. So R55, 25.8 millivolts. R53 equals bang on 25. R54, 26 millivolts. So what is the value of these emitter resistors? 0.47, 25 millivolts, exponential -3 divided by 0.47, 53 milliamps. So if I've done that right, that current's about twice what it should be. It should be around 25 milliamps, and we're actually getting something a lot higher than that. We're getting 53. So my thoughts are that either the service data that I've got is incorrect, or this does need adjusting. But I'm almost hesitant to touch it, because I do think everything is running relatively cool, and the amplifier sounds really good. So yeah, I'm thinking, should I adjust it or not? I guess there's not a lot of point in having the service data if you know, we ignore it, and we can always put it back to the previous value. Now I think that there's only actually two adjustment pots on here, because I think I said earlier there is no DC offset voltage adjustment on these amplifiers, not a variable pot for it anyway. So the only adjustments I can see are these two resistors here, and I can't see a designator for them. Let's just have a look at the data sheet. To me that looks like VR5 and VR6. Have they got a number on it to stick my head in front of the camera? No, there isn't a designator on there. I guess the thing to do is to have a twiddle. At the end of the day, I can always put it back, can't I? But yeah, I'm very hesitant to adjust it, mainly because I don't exactly know what I'm doing. But I'm sure if I'm done something wrong, you guys are going to shout out and tell me. So let's have a go. Well, I've managed to attach some mini grabber probes to across that emitter resistor, which is 0.47 ohms, and I've had everything switched off for a little while, and a lot of the well, not a lot of them, the voltages that we previously measured across the emitter resistors do seem to have dropped a little bit, but they are creeping back up. Now, from what I can tell, we're actually looking for a bias current of 25 milliamps, which will equate to a voltage of 12 millivolts across those resistors. So what I've done is I've given both of the trimmer pots a little bit of a squirt of service-all, and I think what I'm going to try and do now is to see if I can tweak this voltage back down. Now I'm assuming this is the correct pot, so let's have a go. I think that's going to be good enough. It's certainly a lot lower than it was a minute ago. I'm just going to turn it off while I take these grabbers off, because not very easy to get on and off, and I might short something out. Right, we're just on the other bias. I've just connected up to the other emitter resistor now, and we're just going to see if that's anything similar. So I've adjusted the bias now, and I've set the emitter resistors as best that I can to have 12 millivolts across them. So let's just double check that. So 11.8, 11.4, 11.8, 11.9, and I think they're all pretty close, and I'm guessing that's going to be okay. But that's quite a big change, because what did we start at? Well, we started off with, I think I said 53 milliamps going across them, and now according to that adjustment we'll now have 25. So that seems like quite a big change. I guess the proof of the pudding will be to see if it still sounds okay. I know from watching some other YouTube videos that some people like to increase the bias a little bit more. I guess maybe it helps with any type of crossover distortion if the if the transistors are turned on a little bit harder as they cross over. And I wonder if that's what maybe somebody's done in the past. They've tweaked that up because it is double. It was originally double what the manufacturers said. So I'm really not sure if that's right or wrong. Anyway, let's plug a speaker in and I guess just do a quick listen test. Does it still sound okay?
Is affordable at Snell & Robbins, and that luxurious feeling begins when the Snell & Robbins delivery vehicle arrives at home. Why pay?